Welcome back to eCoreAcademy, everyone. My name is Anita and I am one of the teachers and co-founders here, along with my younger brother, AJ Raj. As you can see, this is a new Algebra 2 lesson, and we're just going to be moving along in our polynomial unit. We are somewhere between the middle to the end, so we're in that later half of the unit, and in this lesson, we'll specifically be looking at how are we going to solve these polynomial equations that we've familiarized ourselves with through graphing, through factoring, through doing different word problems with them as well. So now we're finally going to be solving them. In this video specifically, we'll be reviewing the 6 methods of factoring that we've come across over the last quadratics unit, and even at the beginning of this polynomials unit, we'll be putting together those 6 methods, and then I'll be reviewing all of them for you. And we're going to be using these methods for 2 problems at the end of the video where we're actually going to be solving polynomials by setting these polynomial functions equal to 0. Remember, when we set equations equal to 0, we are pretty much trying to find the roots, the solutions, the x-intercepts, the zeros of that polynomial function. So that's what it means by what it means to solve a polynomial equation. Just like we did with quadratic equations, where we found out what x was equal to make the whole equation equal to 0. And before I get into the video, I just wanted to give a quick nod to the little joke I have up here. I remember my Algebra 2 teacher actually showed this very same image to us. It's a teacher talking to a student, and the teacher is saying, algebra class will be important to you later in life. And you might be thinking, yeah, it's going to be important to me because of the higher level math I'll be taking, for the statistics classes, for the calculus, pre-calculus classes I'll be taking later in high school and even in college. But what the teacher really means is it's important to you in the future because there's going to be a test 6 weeks from now. So we're not the teacher's not even talking about like your far future. It's like the near future. So I thought that was a bit funny, and the students just looking at the teacher like, oh my god. So before I get into the video, I would really appreciate it if you could like, subscribe, comment down below, hit the post notification bell, and share using all our socials, and we will get right into it. So first, we want to understand what this whole lesson is about by reviewing some lesson concepts. Here are the key ideas I want you to keep in mind as we're going through this lesson. The point of this lesson is to solve polynomial equations by factoring. So we're going to go through those 6 methods of factoring, review them all thoroughly with examples for each one. And we've already gone through all of them. I'm not going to be showing you anything new in this video, so it really should just be a refresher. Then we're going to use these polynomial factoring techniques with the last 2 problems, so we set them equal to 0, factor, and then we can solve for x. So those are our 2, and then that's what we want to do. And then our last, the very last problem in this video, we're actually going to be using the TI calculator, and we're going to be looking at a word problem, and from that word problem, we're going to come up with a polynomial function to represent the word problem. Then we're going to find our solutions by graphing. So I'll show you how to do that as well, just in case you're allowed to do that on an assessment, because graphing with the TI calculator is usually faster than doing work by hand. Here are some factoring methods that I just want you to keep in mind, because this is going to be really the basic process we're going to be using to solve these polynomial equations. So first, you want to write the equation in the form p of x is equal to 0. So if you have an equation, for example, x squared plus 4x plus 4, that's a perfect square trinomial. Is equal to p of x. What you want to do is you want to take that same equation and you want to set it equal to 0. So what you're going to do is you're going to rewrite it as x squared plus 4x plus 4. So I'm literally just going to write the example here for you. So x squared plus 4x plus 4. So you got this quadratic perfect square trinomial. Your first step is to set it equal to 0. This whole thing right here is the function, so this would be p of x. Next thing you want to do is you want to factor p of x as much as you can. So in this case, like I said, it's a perfect square trinomial. So it's x plus 2 times x plus 2 is equal to 0. So you just want to factor it using one of the 6 factoring methods, or you could probably use more than one depending on what you're given. And then you want to use the zero product property to find the roots or zeros. The zero product property, I actually wrote it down here. It's defined as if a times b is equal to 0, then a has to be equal to 0 or b has to be equal to 0. Remember, whenever a number is multiplied by 0, the product is going to be 0. So if we have 2 numbers a, b times each other, at least one of them has to be 0. So A or B, or maybe even both of them, has to be equal to 0. So that's why in this case we set one of these equal to 0, because you have the same expression in both the parentheses. If we set x plus 2 equal to 0, we find that x is equal to negative 2. And that's how we would solve. All right, let's move right along into, here's a concept summary. So here's a table of polynomial factoring techniques. So here are the 6 of them. The technique is shown on the left column, and then the formulas that you can follow are shown on the right. So the first one is factoring out the GCF. Remember, GCFs are the greatest common factor. So what you're going to do is you're going to factor out the greatest common factor of all the terms. So let's pretend, for example, we're looking at a cubic polynomial of 4 terms. So we look at the 4 terms and we see which is the greatest common factor, which is the largest number that we can divide each term by evenly without having any decimals, where we're only leaving an integer behind. So that's going to be one of the very first thing you want to look for. Then we're going to be talking about a scenario called quadratic trinomials. So that's pretty much when you have ax squared plus bx. Ooh, I don't know why it says ax squared plus bx plus c squared. This is supposed to say, I have no idea why it says that, ax squared plus bx plus c. This is your quadratic trinomial. You should be pretty familiar with that. That's quadratic standard form. So whenever you have quadratic trinomials, you can pretty much use that guess and check method we talked about, where you take the last number, which is going to be a constant, which is c, then you look at its factors, you break it apart, and then you see which ones will add together so that you can get b. So you're probably pretty much finding factors with the product of a, c. So what you're pretty much doing, I know this is kind of confusing how they worded it, but you're pretty much multiplying a and c together. Usually a is equal to 1, so that's why I say we look at the factors of just c, because any number times 1 is equal to itself. But in cases where x was not equal to 1, maybe it was 2 or 4 or whatever, then we had to kind of rearrange our factors. But in most cases, it's going to be 1. So you're pretty much trying to find factors that multiply to whatever a times c is, and then add together to get b. Then you're going to look at perfect square trinomials, which we already talked about. Perfect square trinomials are pretty much where you have usually they multiply out to quadratic trinomials, but you'll have 2 sets of parentheses with the same expression in both of them. So in this case, a plus b squared is the same as a plus b times a plus b. And if you multiply this out, you're always going to get the standard a squared plus 2ab plus b squared. And then a minus b squared is just equal to a minus b times a minus b. And if you multiply that out, you'll get a squared minus 2ab plus b squared. Then you have difference of squares, where you're subtracting one number from another, and both of them are squares, perfect squares. And you can actually just factor this into a plus b times a minus b. And what happens is the middle terms will cancel out. So then the negative ab, if you multiply this out, you'll get a squared minus ab plus ab plus b squared. So minus b squared, and the ab terms will cancel each other out. Then you have factoring by grouping. Usually you have a polynomial of 4 terms, maybe even more. It's usually even, but that's not to say that it's always even. You're usually going to just group them, and you're going to split. You usually have 4, so you're going to split them into 2 groups. Then you're going to pull out the GCF, so you're also using that GCF method. And then whatever you pull out from both sets of if you have 2 parentheses, whatever you pull out as the GCF from both sets of parentheses, you'll combine into 1 set of parentheses. And whatever was left in those 2 parentheses, for example, here, what I'm saying is a plus x is left in this set, and x plus y is left in both of these sets. So you can combine them together, and you'll have this one of the factors. Make sure that it's the same numbers occurring in both of these parentheses. Then you'll take the GCFs a and b, and you'll combine them in the second set of parentheses. Lastly, you got sum or difference of cubes. We already went over this. Similar to difference of squares, except you have both the sum and difference. Whenever you're adding 2 numbers that are perfect cubes together, you can literally rewrite it as in factored form as a plus b times a squared minus ab plus b squared. And if you're subtracting them, you can write them as a minus b times a squared plus ab plus b squared. You're just going to have to memorize that. Okay. Now that that's out of the way, let's get right into the problems. So problem number 1 is factoring out the GCF. This one's not going to be too difficult. So here's the problem. Factor the following by factoring out the GCF. So here's your solution already pre-written for you. I'm going to go through the problem again with you pretty quickly. All right, so here's our problem. 6x squared y minus xy minus 2y. So we're trying to determine what is the GCF? What can we pull out of each of the three terms here? Well, if I look at each of them, they each have a y. So we're looking for what do they have in common. So our GCF, that's the only thing they have in common. They all have a y. So our GCF is going to be y. So if I pull out the GCF, I'm going to rewrite this as y times 6x squared times y divided by y. It's just going to leave you with 6x squared. Negative xy divided by y is just going to leave you with a negative x, and then a negative 2y divided by y is going to leave you with a negative 2, and here we got a more simplified quadratic trinomial. Now we're going to factor this with our guess and check method, with our quadratic trinomial method. So we're going to look at the factors of just 2. 2's factors are 1 and 2. Okay, so using these factors, we're also going to look at factors of 6. We got 1 and we've got 6. 1 and 6, and we also have 2 and 3. So we're going to see how can we match these up so that we can create two set of parentheses with the two factors in them. For the sake of time, I'm just going to tell you the answer, but at this point, with all the practice you've done, you should be able to look at these and determine that your pair is going to be 2 and 3 and 1 and 2, obviously. So you're going to put 2 and 3 in these two sets of parentheses. You can put it as 2x in one and 3x in the other one. Remember, we're making them x's because they're going to end up multiplying together and giving us the 6x squared term. So they both are the coefficients of these x terms. And then we're going to have to determine what the signs of 1 and 2 are. We're going to have plus 1 in this set of parentheses and minus 2 in this set of parentheses. If you multiply this back out, you'll get 6x squared minus x minus 2, but you won't get the original equation because you have to add that y in the front, and that is your final answer. All right, so let's go to the next problem. We're looking at quadratic trinomials. So we're going to factor the following quadratic trinomial. Here's your solution pre-written for you. Here's the answer, and we're going to run through it again. All right, so let me rewrite this quadratic trinomial, 6x squared plus 11x minus 10. First thing we want to do is look at the factors of negative 10. We've got 1 and 2, and we've also got 2 and 5. Sorry, 1 and 10 and 2 and 5. Then we want to look at the factors of 6, which are 1 and 6 and 2 and 3. And we're trying to pick which ones will go together so that we compare them in parentheses so that we can end up making them the factors so that they multiply out. We also want to focus on this 11x, and we're going to do this with our guess and check method. Guess and check. So we're going to try all these possibilities. The better you get at it, the faster it will be, and you're going to be able to do it in your head. And for the sake of time, I'll tell you that we're going to pick 2 and 3, and we're also going to pick 2 and 5. And I'll just write out the parentheses. It's 3x minus 2. These are going to be our factors, 2x minus 2 times 2x plus 5. And that's going to be your final answer. And I want to bring back this concept of the product of a times c. So a times c is going to be 3 times 2. Because what we do is with the product of a times c, we're pretty much multiplying 6 and 10 together because this is a, this is c. So the product of a times c is the product of all of the factors. The factors are 3, 2, 2, and 5. In this case, we're just going to ignore the x's. So 3 times 2 times 2 times 5 is going to be equal to, negative 2. This is supposed to be negative 2. So 3 times negative 2 is negative 6 times 10, which is going to be equal to negative 60, which is the same as saying 6 times negative 10. So this is going to be your product of AC. Product AC. And then you've got B is equal to the sum of the factors. So you have 3x times 5, because remember FOIL, 3x times 5, and then negative 2 times 2x. So 3x times 5 plus negative 2 times 2x is going to give you 3x times 5 is equal to 15x. And then negative 2 times 2x is going to give you negative 4x, and that's going to give you 11x. And then together, this should give you the sum of b. So that's what that terminology meant on that slide with the table. All right, so let's go to the next problem. This one is going to be on perfect square trinomials. So it's going to be pretty straightforward. You're going to factor the following perfect square trinomials. We have 2 because there were 2 instances where the sign is different. In some instances, you'll have the x squared and the x squared and then the bx term separated by a plus, or you'll have the ax squared term and the bx term separated by a minus sign. It's literally the same equation, but I'll show you how to write it in case you get it in these two different forms. So here's your solution per in. We'll run through that again now. So first I'm going to rewrite it. The first one, x squared plus 14x plus 49. We see the plus sign. We want to acknowledge that so we know which perfect square trinomial formula we're going to use. And we want to acknowledge that the factors of 49 are 7 and 7. So that's going to be our perfect square trinomial because these are both the same exact number. So we want to know our formula. Our formula is a squared plus ab plus b squared, which is this situation we have right here, is equal to a plus b times a plus b. Or we can just say a plus b squared. So if we want to factor this, we have x plus something in this set of parentheses times x plus something in this set of parentheses. What's going to be the 7? Or we can write this as x plus 7 squared, because the two sets of parentheses are identical. They're getting multiplied together, so squared. So that's how we would do the perfect square trinomial. The x's multiplied together give us the x squared. If we distribute the 7s, we get 7x plus 7x, which is going to give us the 14x. And then if we multiply the 7s, we'll get 49. Keeping that same thought, we'll do the second one. So x squared minus 14x plus 49. Again, we want to acknowledge we have a minus sign, so our formula is going to be a bit different. And 49's factors are 7 and 7, which will give us that perfect square trinomial because we're going to have the same expression in both sets of parentheses. So what equation are we going to use now? Well, because we have a minus sign, it's a squared minus ab plus b squared. And this is going to be equal to a minus b times a minus b, or we can write this as a minus b squared. So if we write this out, we're going to get x minus 7 times x minus 7, or you can just write it as x minus 7 squared. All right, that's done. Let's go to problem 4, difference of squares. So here's our problem, factoring the following difference of squares. Here's our solution pre-written for you. And even before we get into the solution, I just want you to look at both of our terms, 4x squared, which is technically our a squared, and then 15, which is our b squared. And you're probably thinking 15 is not a perfect square, so we technically cannot factor this. Well, in some situations you can say that, but we're looking at an honors algebra 2 course, so you're going to be expected to factor even these situations where you don't have perfect squares, and I'll show you how to do that. All right, so we're going to just write this as our difference of squares. That's a squared minus b squared, something we're pretty familiar with. And then we're going to factor this to a plus b times a minus b. We also remember that. We write it this way because if we distribute it, we'll get a squared minus ab plus ab minus b squared, so that the ab terms cancel out. So this is literally going to be the problem we have. So 4x squared minus 15. Let's look at our a term first. So this first term is actually a squared. It's not just a, it's a squared. A squared is equal to 4x squared. So we want to square root both sides to get just a. So if we square root both sides, we're getting the square root of 4x squared. So the square root of 4 is equal to 2, and the square root of x squared is equal to x. We want to do the same thing with this side because this is b squared. B squared is equal to 15. So to get b by itself, we're just square rooting 15. So these are the two values that we're going to work with right here. So when we factor it, we're going to end up getting 2x plus root 15 times 2x minus root 15. Because we're going back to this formula that we had right here. The root 15 can't be simplified because 15's factors 1, 15, 3, and 5. None of those are perfect squares either, so we're going to just leave that under the radical sign. So that would be your final answer. All right, let's go to factoring by grouping. This is what we actually looked at in the previous video. So factoring by grouping. Factor the following by factoring by grouping. That's a lot to say. X cubed plus 2x squared minus 3x minus 6. And here's your solution. All right, so we're going to run through this quickly as well, taking a note that this is a cubic polynomial of 4 terms, and this is usually what you're going to get when you look at factoring by grouping, you're usually going to have 4 terms, like I said, and it's usually a cubic. I've seen quartics as well, but again, take my words with a grain of salt because you never know what your teacher is going to give you. So this is usually the form you're going to see it in. That's why I use it as an example, but just be prepared for everything. As you do more of these problems, like I said before, you'll be able to tell which terms you want to group together so that you can factor and you can get the same expression in both parentheses so you do it correctly. All right, so we're going to get right into this problem. I'm going to rewrite it. X cubed plus 2x squared minus 3x minus 6. So how are we going to group this? Well, we can just group the first 2 terms together because they have x's in common. We can group the second 2 terms because they have 3's in common because 6 goes into 3. 3 goes into 6 and 3 also goes into itself. So we're going to just rewrite these as parentheses just to separate them. X cubed plus 2x squared in one set of parentheses. X cubed plus 2x squared in one set of parentheses, plus negative 3x minus 6 in another set of parentheses. Now we want to plot the GCFs, so we're going to identify what the GCFs are. In this case, the GCFs, we can obviously look at the x's because that's what these 2 terms share, and largest x we can pull out is an x squared. We can't pull out an x cubed because there's only an x squared in this term, so we're going to pull out that complete x squared. In this set of parentheses, our GCF, we can't pull out any x's because the negative 6 doesn't have any x's. We can pull out a negative 3 because negative 3 divides into negative 3 and negative 6. So we're going to rewrite this as, after pulling the x squared out, x squared times x cubed divided by x squared is x. 2x squared divided by x squared is just 2. So we're going to have plus 2. If you pull out the negative 3, we're going to have negative 3x divided by negative 3, which is just x, and negative 6 divided by negative 3, which is just going to give you plus 2. We know we did this correctly because we get x plus 2 in both of these sets of parentheses. So we're just going to finish this off by putting the x squared and the negative 3 in one set of parentheses, and the x plus 2 in another set of parentheses, and this is our final answer. Okay, last problem, I believe, and this is just going to be sum or difference of cubes. So the problem is factor the following sum or difference of cubes. We have 27a cubed plus 8b cubed. We also have literally the exact same exact polynomial, except we have a minus sign between the terms, and I just did this on purpose so I could show you how we have 2 differing, we're going to end up getting 2 different factorizations. We're going to have pretty much the same a and b terms. So here's your solution pre-written for you. I'm going to run through this again with you. So the first one we're just going to look at is 27a cubed plus 8b cubed. And again, we want to acknowledge that this is a plus sign. So this is a sum of cubes. We're adding the cubes together. And the formula we use for sum of cubes is a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And again, you're just going to have to memorize this. On the flip side, with the second equation, it's 27a cubed minus 8b cubed. So this is a difference of cubes because of the minus sign. So we end up getting a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Again, something you're just going to have to memorize. So let's figure out what our a and b terms are so we can factor this. Because in this situation, the 27a cubed is common and the 8b cubed is common. All we're going to be changing is the signs. The a and b values are the same for both of these polynomial functions. So a cubed is technically equal to 27a cubed that we were given in the problem. To get a by itself, we're going to have to cube root this 27a cubed. 27a cubed. The cube root of 27 is 3, and the cube root of a cubed is equal to a. So a is technically equal to 3a. B cubed is equal to 8b cubed. So b by itself is equal to the cube root of 8b cubed. If we cube root 8, we're going to get 2, and if we cube root b cubed, we're going to get 2. We're going to get b. So our answer here is 2b. Our answer here is 3a. So we're going to use these to factor these different sum and difference of cubes. So for our sum of cubes, we're going to end up getting 3a plus 2b. And remember, I'm just following these formulas that we wrote out. So 3a plus 2b times a squared would be 3a squared, and 3a squared is equal to 9a squared, plus 3a times 2b, which is going to give you 6ab, plus b squared, which is 4b squared. So that's going to be our factorization of that. On the flip side, we're going to have the exact same thing here. So I'm literally going to rewrite it, except the first set of parentheses, we're going to have a minus sign between 3a and 2b. So 3a minus 2b times 9a squared. Ooh, and sorry, this is not supposed to be a plus sign. This is supposed to be a minus sign. Even I'm messing up. Okay, 9a squared plus 6ab plus 4b squared. So in the difference of cubes, here we got a plus sign. In the sum of cubes, here we got a minus sign. So this is going to be your factorization here. All right, so those were our examples. So we're going to move into a problem where we're actually going to be solving polynomials. So we're going to be setting it equal to 0, factoring, and solving for x. So here's our problem. Find the real or imaginary solutions. So we're not just looking for the real solutions, we're also looking for solutions where there's an I involved. Remember, I is equal to the square root of -1. That's not real because we can't take the square root of negative numbers. We've already gone over this, and we're told that we can find these imaginary solutions. We're not just going to say that they don't exist because we're looking at the imaginary number plane, and we're also looking at the real number plane. And remember, I squared is equal to -1. All right, so let's look at the solution. As you can see, we're going to use the quadratic formula. That's going to come back up. And the reason I picked this problem to do is because we'll have a lot of important elements that we'll be going over. So here, let's rewrite the problem. 3x to the fourth plus 12x squared. I actually want to write it further to the side so we get more problem for the quadratic form, more space for the quadratic formula. So we have 3x to the fourth, plus 12x squared minus 6 equals 6x cubed. So the first thing we're going to do is we're going to set p of x, which is this whole p of x is equal to this whole polynomial function. We want to set it equal to 0. To do that, we can subtract 6x cubed from both sides. So we get 3x to the fourth plus 12x squared minus 6x cubed is equal to 0. Then we want to just rearrange this in proper descending order. So 3x to the fourth minus 6x cubed plus 12x squared is equal to 0. And the first step we want to do is we want to GCF because you can see that this definitely has a greatest common factor. And the greatest common factor, well, if we look at the coefficients, it's 3. And if we look at the x's, our variables, it's x squared. So we're going to factor out a 3x squared. And if we put 3x squared from 3x to the fourth, we get an x squared. Negative 6x cubed divided by 3x squared is going to give you a negative 2x. And 12x squared divided by 3x squared is just going to give you a 4. And this is going to be set equal to 0. We can find our first solution because here what we do is we actually take the 3x squared because you can think of it as in its own set of parentheses. We can't factor this any further, so we can just set this equal to 0, and we can immediately find our first set of solutions. So if we set this equal to 0, we can divide both sides by 3. We get x squared is equal to 0 because 0 divided by any number is equal to 0. We get x is equal to 0. But remember multiplicity where we have a 0 occur more than once, we have a multiplicity of 2 because when you square root something, you're taking both the positive or the principal root and you're taking the negative root. So, for example, if we square root the number 4, technically there's two solutions, positive 2 and negative 2. Because positive 2 times positive 2 is equal to 4, negative 2 times negative 2 is also equal to 4. Therefore, when you square root 0, you can, even though 0 is not considered a positive or a negative number, you still say that there are two roots. So you have x equals 0 with a multiplicity of 2. So just keep that in mind. However, we're not done yet because we have this whole quadratic trinomial here that we still need to factor. I'm just going to skip ahead and just tell you right away that you cannot factor this by our guess and check method. It just doesn't work. So we're going to have to use the quadratic formula. Remember, the quadratic formula is used so that you can solve any quadratic equation. It doesn't even have to the guess and check method can still work, but you can literally use this for any quadratic trinomial in the standard form ax squared plus bx plus c. You can use this for any of that. So I'm going to rewrite it. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Again, just something you're going to have to memorize. So if we plug in the values from this quadratic trinomial here, we get with 1 being our a, -2 being our b, and 4 being our c, we end up getting 2 plus or minus the square root of -2 squared minus 4 times 1 times 4 over 2 times 1. We simplify this, we get 2 plus or minus the square root. -2 squared is 4. -4 times 1 times 4 is equal to -16 over 2 times 1 is equal to 2. So then what we do is 2 plus or minus 4 minus 16 is equal to -12 over 2. And if we look at -12, -12's perfect square is 4. If you look at its factors, you have 1, 6, 3, and 4. 4 is a perfect square. 4 square rooted is 2, so we can pull 2 out of the radical. So we end up getting 2 plus or minus. We can also pull a -1 out of the radical because this is a -12. So we get 2i square root times square root of 3 over 2. And because these are all 2's, like the 2 right here can cancel out with this 2 and this 2. So our final answer would be 1. Oops. Because 2 divided by 2 is equal to 1. So we end up getting 1 plus or minus I root 3. So x is technically, I'm going to write it up here, x is equal to 1 plus or minus I root 3, and it's also equal to 0. Don't forget the 0 we found at the beginning with a multiplicity of 2. All right, so we're done solving that. Our last solving problem is actually looks kind of difficult, but it really isn't. So find the real or imaginary solutions of this polynomial equation. Here's your solution pre-written. It's actually very, very short. So I just wanted to throw this one in just to show you that even though it might be a bit long-winded and look painful, it really is not if you just stay smart about it. So first what we're going to do is I'm going to rewrite what we've been given, x times x squared plus 8 is equal to 8 times x plus 1. If we distribute the x, we should start by distributing the x on this side and the 8 on this side. So x times x squared is x cubed plus 8 times x is 8x is equal to 8 times x, which is also 8x on the right side, times 8 plus 1, which is equal to 8. Then what we're going to do is we're going to try to move everything to the left side so that we can set this polynomial equation polynomial function p of x equal to 0 so that we can factor. So what we're going to do is we're going to subtract 8x from both sides, and what that does is that cancels out the whole 8x term that we're going to subtract 8 from both sides. We end up getting 8x cubed, minus 8 equals 0. What you can do now is you can actually add 8 to both sides because you can take the cube root of 8 and you can solve this. So if you take the cube, if you rewrite this as x cubed equals 8, so leaving the 8 on the right side, you can then take the cube root of both sides and you'll get x is equal to the cube root of 8, and the cube root of 8 is equal to 2, so x is equal to 2, and that is your final answer. Okay everyone, so I've switched to a view of my calculator because we're going to be doing a quick problem on the graphing method. So I'm going to show you how you can graph a polynomial function and then you can find its solutions using the graphing calculator, the TI calculator specifically. And the reason I wanted to show you this is because it can save you a lot of time on assessments, especially when you're allowed to use this graphing utility, because doing all that work by hand, as we saw in the previous problems, is going to take a lot longer than when you just have the calculator do it for you. Okay, so let's look at the notes I have to the left. The TI can be used to find the real zeros of a function, not the imaginary ones. Remember, real zeros are just on the real number plane, which is what the TI calculator graphs in. The TI calculator does not graph in the imaginary plane, where one of the axes represents I, which is your square root of -1. So the TI calculator is going to graph on the real number plane. If you have any imaginary roots, you're going to unfortunately have to find them by hand. But for our scenario here with this problem, we won't have to worry about imaginary roots. Okay, let's read the word problem I have. 3 friends were born on July 4th. Stacy is 1 year younger than Una. Una is 2 years younger than Amir. On July 4th, 2010, the product of their ages was 2,300 more than the sum. How old was each person on the birthday? Okay, so we have three friends and they all share a common birthday, which is July 4th. The three friends are Stacy, who's the youngest, Una, who's the middle, and Amir, who is the oldest. Now, in this problem, we're looking at a specific birthday which occurs in the year 2010. And what we're being told, the information we're given is that their ages multiplied together plus 2,300 is, their ages multiplied together is 2,300 more than their ages added together. And we're asked what is the age of each person. So from this, we got to come up with expressions to represent each of their ages. We can use Amir as our basis of comparison because we're told the ages of Stacy and Una relative to Amir. So Amir can equal X for us because we're not necessarily told what his age is. We're told what Stacy and Una's ages are relative to his. Then if we have Amir as our X, we can then decide what Una's age is going to be. We're told that Una is 2 years younger than Amir. So if Amir is So she's pretty much Amir minus 2, since Amir is X, Una is X minus 2. Stacy, on the other hand, is 1 year younger than Una, so Stacy is Una's age minus 1. Una is 2 years younger than Amir, so technically Stacy's going to be 3 years younger than Amir, because Una's 2 years younger than Amir, Stacy's 1 year younger than Una, so Stacy is 1 plus 2, which is 3 years younger than Amir. So she's going to be Amir minus 3, so she's going to be X minus 3. Then what we do is we've been told that their ages multiplied together, x times x minus 2 times x minus 3, as you can see, is equal to all their ages added together plus 2,300. So that's how we set up that equation. X times x minus 2 times x minus 3 is equal to x, which is Amir's age, plus x minus 2, which is Una's age, plus x minus 3, which is Stacy's age, plus that 2,300. So that's how we set that equation up. We can simplify the right side of the equation by combining the x's to get 3x. If we subtract -2 and -3, which together is -5, from 2,300, we get 2,295. So we can just combine like terms on the right side, and we have that second equation. That's what we're going to plug into the TI calculator. So first I'm going to go to my y equals, and in my y1, I'm going to write x times x minus 2 times x minus 3 for the product of their three ages. And in y2, I'm going to write 3x plus 2,295. Now what we're going to do is, before we even graph, I'm going to go to adjust my window because these are some pretty big numbers. I'm going to change my y min to -50, my y max to 50, my x max to 50, and my x min to -50, my y min to -50, but I'm going to crank my y max up to 3,000. Because if you see, we're working with a 2,295, so that's going to be our y-intercept. That's pretty high, so we're going to go up to 3,000. So if I hit graph, you're going to see two functions graphed. This is our cubic, which is the product of their ages, and this is our linear, which is the addition part. Next, what we're going to do is we're going to just find the intersection, which is pretty straightforward. Second, trace, 5 for intersect, and then you just hit enter 3 times 1, 2, 3. And you're given that x is equal to 15. I know it's kind of hard to see. X is equal to 15. Y is equal to 2,340. We just want to focus on the x is equal to 15 because remember, Amir's age is, like we said, x. So technically, Amir is 15. So we have our first answer. Una is 2 years younger, so 15 minus 2 is 13. And Stacy's 3 years younger, so 15 minus 3 is 12. That's how we use the TI calculator to solve. We found the intersection of the two functions that we came up with. Alright, that's all I have for you today. I hope you enjoyed the video. We did go through a lot of concepts, but I do think it was a great review. There was a table at the beginning that really straightened out all of the factoring methods we've learned. And we looked at a bunch of examples, and then we did 2 problems just to familiarize ourselves with implementing different factoring methods. Then we did a graphing problem. Not only did we look at a word problem, but we saw how using the TI calculator can make the process so much faster. So I hope you enjoyed. If you did, please hit the like button, the subscribe button, the post notification bell, drop a comment down below, and share using all our socials. Also, check out our website and our Gmail. Thank you for watching, and stay tuned for the next Algebra 2 video.